Okay, so for question 13, the ft is a product of two functions, okay? One is the linear, and the other one is the exponential. So, whenever I do, if a is a constant, I will not put a as my u. So I will put this as my u, and I will put my v as e to the power negative bt. Okay, so I will differentiate it. V prime, everyone should know, correct? Copy down the whole thing, times by the derivative of the power. Okay, done with that. Then we sub into the products rule. Okay, so f prime t, that is, you put the a outside here. Can someone switch off your mic? Ashvindaran. Ashvindaran.
Yes, ma'am. Sorry, yes.
Can you please go to a place whereby there's no noise, whereby you can focus and study?
Yeah, sorry, miss. Yeah, sorry, miss. Yeah, that's my fault. Sorry.
Off it, please. Okay, so V U prime plus U V prime. Okay, then you factorize out the common factor. So it will be here, be careful. There's a minus here, so it becomes minus BT. So the first part, first part, you are supposed to find the local maximum. Okay, so you put f prime t equal to 0. Yep. So a e to the power negative bt times 1 minus bt equal to 0. A cannot be 0. E to the power negative bt equal to 0 is no solution. And the other one is 1 minus bt equal to 0. So t equal to 1 over b. Okay, I got that. But I have to prove that it is a local maximum. Since the question said local maximum, so you just do it for formality's sake. F prime t, F prime t, you draw the sign diagram. T is about time, so you put 0 here onward. And you put your 1 over b here. Maximum, the graph must be here, must be positive, here must be negative. Okay, so you got that. Okay, so the question just asks you a local maximum at t equal to 1 over b. Done? So, but we also want to know the y coordinate. So this is something that extra that I put down here. So I want to know when x equal to 1 over b. Yeah, what is my y? So a 1 over b e to the power negative b times 1 over b. So cancel, cancel. So you got a over b. This is e to the power negative 1. So this will be your y coordinate. So the coordinate of the maximum point will be 1 over b, a over be. So this is something extra. Okay, so done with that. We are done with first part. Okay, then a point of inflection. So if we want to know the point of inflection, we have to differentiate f the prime x again. Am I right? So for part 2, my f prime x, f prime t is a e to the power negative bt and 1 minus bt. So I will take this as the u and take this as the v. So my u is e to the power negative bt. Okay. So, okay, Carol Rampa, what is u prime?
U prime is e to the power of negative bt.
That's all?
And then bracket negative bt.
Huh?
Oh, negative b.
Carol Rampa, how to go for SAT 2? Things that you are supposed to know, please. Okay, v is 1 minus bt. So what is v prime? What is v prime? Idina. What is dv over dt? Idina. Yes. Ashwindaran, what is v prime t? Here.
Yeah, okay. I'm looking at that. Will it just be BT by itself or?
No, you're really, I off the record first. Cindy? Cindy not in. Cindy, are you here? Hmm? Oh, Cindy is not in this class. Okay. Chunyi?
Minus b.
Yes, negative b, you're right. Okay, we are done with that. So we put into our products rule, f double prime t equal to, remember to put the a. Okay, v, remember to put in the bracket, u prime, okay, plus u v prime. Okay, so you look, the common factor is this whole thing, right? So you factorize out the common factor. So negative a b e to the power negative bt, open bracket, 1 minus bt. This whole thing you take out already, you have to put plus 1. So you got negative a b e to the power negative bt 2 minus bt. Okay, for inflection point, f double prime t equal to 0. So I straight away write down negative a cannot be 0, b cannot be 0, e to the power negative bt equal to 0, no solution. And 2 minus bt equal to 0. So t equal to 2 over b. So I have proven that. And this point of inflection, we call it a non-horizontal point of inflection because this value doesn't appear here. Non-stationary inflection point. And if you look at 2 over b. So if we, okay, so I proved that I've done whatever I need to. So if I draw a f double prime t sine diagram, start from 0 onward, and here is my 2 over b. Do you know how am I going to determine the sign? Look, if it's less than 2 over b, if your t is less than 2 over b, so you look at the one that control the sign is this factor, because your f double prime is this one. So I can also determine the sign even without number. So 2 minus bt. So if t is less than 2 over b, this whole thing will be greater than 0. So here is a negative. So therefore here is negative, and here will be positive. So a lot of things in maths, even without number, I can judge whether the whole expression is positive or negative. So that means why I want to do that is because part B, they asked me to sketch the function, show the feature you have found. So there are two features. One is the stationary point. One is the point of inflection. Okay, so we have this and the point of inflection. So I'm going to sketch the graph, yeah, on the other page. So when I sketch the graph, I try to make it big, so that I can show other things. Okay. So this is my axis. One over b. The other one is double 2 over b. Okay, when x t equal to 0, this is 0. And here is the highest point. Okay, and if you look at f prime t sine diagram, so I draw again, it go like that. 1 over b. Here is positive, here is negative. So this part, the graph is going up. And if I look at f double prime t sine diagram, here is negative, here is positive, means here fx is concave downward. Okay, concave down. So go up. Then after that, come down until this point. Okay, up to you. I don't know what is the value. Yeah. So after this point, okay, so then it continue with concave upward, and it will not reach 0 because as t approaches infinity, e to the power of negative bt approaches where? Approaches where? Nadidi? Nadidi
Yes, Miss.
approaches what? As t approaches infinity, e to the power negative bt will approach
Zero.
yeah. Okay, because I told you when it's power negative, we always write like that. Am I right? Then you will know what to do. So therefore, ft will approach because ft is what? A t e to the power negative bt. This one approach zero, correct? So anything times zero will go zero, but this is above, from above. Okay, that's why the graph go this way. See or not? So these are the important feature. So you have to write down 1 over b and the coordinates. So everyone in your notes for SAT2, everyone, you should have information about this search function. So, and the maximum value is from here, A over BE. And it is decreasing at the fastest rate at the time 2 over B. And the Y value will be 2A over B E squared. So this information, you should write it down. Do you know the reason why? Because in the exam, I can set a question like this. I say, okay, given, okay, ft is equal to 5t e to the power negative 0.1 t. Then I will ask you question like, when is the value of ft reach maximum? Okay, I can ask question like that. I only give you 1 mark. Do you know how I answer this part? I got the formula. 1 over, here is your B. That's it. You see or not? So it's very, very important. So these are the questions whereby I give you 1 mark. You want to use graphic calculator to sketch the graph or whatsoever, that is your choice. Or you want to put this information that you can straight away use it. Are you clear? So for search function and logistic function, we want you to record this down. So I can also ask, when is ft decreasing at the fastest rate? Okay, so what is my answer? T equal to 2 over B. That is 20 seconds. That's it. Do you see the importance of it? Okay. So all this information. So this is my Y equal to A T e to the power negative BT. Okay, now, if I want to sketch my dy dx graph, how is the graph look like? So it's good also to include, it will pass through this point, it will turn here. So this is going up, so the graph will be positive. Then it start to become negative and go lowest here. Then after that, it won't just go up. So there is another inflection point someplace somewhere here for, then it go approach zero. So this is your y equal to dy over dx. We have sketched this graph before, correct? I just didn't tell you. Okay, then the f double prime x graph, it will pass by this point, correct? And you see the f prime x, the dy dx is going down. Yeah, so it will be from very negative. I think I use black better. Huh? Oh, sorry. Okay, I use black better. Okay, so it will go up. Okay, then it will pass by this point. Okay, then here is the inflection point. You will turn down, then it will go like that. Okay, so this is your y equal to d2y over dx squared. Or we call it f double prime x. So these are the two possible graphs. Are you okay? So search function, everyone, you should have this in your, and you may quote some of the examples so that you know how to apply it. And you may want to put down the sign diagram also. So you see the FT sign diagram will be always positive. There is no x-intercept. X-intercept is at t equal to 0. All these are talking about time, rate of change. Like, for example, if next time you want to become a doctor, anesthetist, they have to know when they can start the operation, depend on the level of the medicine. Okay? I know all this. Do you know why? Yeah, question 14, please.
Miss,
Yes.
can go back to the previous slide for a second.
Screenshot.
Okay.
Done? This one I will not prepare notes, huh? Okay, question 14. Let's look at question 14. Okay, question 14. Okay, this is called a logistic function. Look, okay, it will be a number divided by, here must be 1, and a constant, e to the power of negative bt. You see the exponential, the power must be negative, and AB, ACB all are positive. You see or not? That the criteria must be fulfilled. Okay, so the first part of the question, they ask us to find the y-intercept. So y-intercept means you put the t equal to 0, correct? So f0. So c divided by 1 plus a e to the power of 0. Okay, e to the power of 0 is what? Is 1. So 1 over 1, c over 1 plus a. So that is the y-intercept. Okay, done with that. Now they ask you to prove that y equal to c is the horizontal asymptote. So as long as you want to prove horizontal asymptote, you must do this part. Anything to do with horizontal asymptote, You must study as. Since t is greater than or equal to 0, so we will study as t approaches infinity. There is no negative part as t approaches infinity. So we have to study this term first. So e to the power negative bt will approach Jen, how?
0.
0. So everyone should be very familiar already, correct? So therefore, my ft, which is a positive number divided by 1 plus a positive number times by e to the power negative bt. That means over here, I will imagine this as c divided by 1 plus 0. So it will approach what? It will approach Sebastian. Sebastian, your surrounding is very noisy. Sebastian, approach what? Might not working out. Okay, never mind. Tell me approach what? Type out. You look at here. Okay. Sebastian or class, you look at this one. This one approach 0. So that's why I put a 0 here. So c divided by 1 plus 0. So it's what? Right, sir?
Is it infinity as well?
Yes. I can't get you, Raisa, again.
Is it infinity?
Hello. Here. How can be infinity? C divided by 1, how to be infinity? You tell me. Raisa?
Why? Because C, is it?
Yes.
Oh, okay.
So this is from below. Because C divided by a bigger number will be less than C. Understand? 0 is the smallest number here. Okay? From below. So then, I got the horizontal asymptote. So therefore, the horizontal asymptote is y equal to c. Done. Are you clear? Okay, if a greater than 1, where is a point of inflection? Okay, so in order to do this case, you have to do double differentiation. So how to differentiate ft first? How to differentiate ft? Class? Anyone? How to differentiate ft? What rule should I use? I want to ask Simran again. Simran, what rule should I use?
The simplest one.
Huh?
The simplest one.
Which simplest one? Okay, tell me which rule. How should
Bracket the below one and then move it to above and then write -1 as a power.
Yeah. Xingren, do you know why Miss Do call you again?
Because yesterday I did the wrong thing.
Yeah. So you see that is called practice make perfect. You make a mistake, never mind. Then you tell yourself, I'm not going to use that again. Correct? So you are using a chain rule. Good, thank you. So F prime T. So not bad, huh? Miss Do memory is still okay. So C, bring down the power. So that is a difference, a max teacher and a non-max teacher, okay? Then power -2. Then you have to differentiate whatever inside here, then put here. So A, e to the power -bt. Then you have to time by the derivative of the power again. Okay? So now you have, here is negative, here also is negative, so it becomes positive, correct? So you have to have, be careful. Negative, negative. Okay, so my top, the top part will be A, B, C, correct? E to the power -bt divided by 1 plus A e to the power -bt squared. Okay. Hello? So now we want to go to the second derivative. So the u we are going to use quotient rule. U is e to the power -bt and v is 1 plus a e to the power -bt, the whole thing squared. So u prime. Okay, u prime. Shinyi, can you tell me so what is u prime? Shinyi?
Yeah, Miss, I'm here.
Yeah, you have to be quick. What is u prime?
1 over EBT.
How to be 1 over EBT, Shinyi? This is exponential, correct? Isn't it you're supposed to copy down the whole thing?
Yes.
Then time by the derivative of the power. Isn't it? Please, class. V prime t using chain rule to copy down the whole thing. Power, take away 1. Time by the derivative of the whatever in the bracket. That means repeat that again. Close. Okay. We try not to do anything because there are too many things already. So we get our F double prime T. Okay, change the color. So the ABC we can just put outside. So you know quotient rule is a fraction. V U prime take away U V prime. So you have to write properly. So I got space problem. So I just write small. Then time by negative b, okay? Then the whole thing over v squared. So square become power 4, okay? So now I'm going to straight away cut. I don't want to rewrite again. So this power become 3. This one cancel off. This one power become 1. Do you see how I do? Okay. So now I can group it. A, B, C. Okay. Common factor here. Okay. E to the power of BT and negative B. So E to the power of negative BT, then negative B. You just take it out, it doesn't matter. Then after that, open bracket, 1 plus A E to the power of negative BT. There is the front one, take away. Here there is a 2 here, there is a A here. 2 A E to the power of negative BT. Close. Divide. So, exam, we may ask you to do like that. Okay. So now, what I need to do is I want to know the inflection point, all right? So what I need to do is this one cannot be 0. So the top is 0. So F double prime T equal to 0. So I straight away write here. From here, I straight away write. I simplify this one. So I straight away write 1. This is A to the power negative BT, take away 2A. So left with 1A. So it's 1 minus A E to the power negative BT equal to 0. So A E to the power negative BT equal to 1. So whenever you have negative, what I will advise you to do is put it as like that, without negative. So E to the power BT is equal to A. So from E, you change to ln. So therefore, the T equal to ln A over B. Okay? So after you get your the time for inflection point, so what you need to do, you need to know the Y. So now I go to here. So my T is equal to ln A over, okay, ln A over B. Or my E to the power of BT is equal to A. So this is the inflection point. So the F ln A over B is equal to C divided by, formula is 1 plus A E to the power of negative, okay, BT is A. So E to the power of, so therefore this implies E to the power negative BT is 1 over A, okay? So I just substitute here, times 1 over A. Cancel, cancel. So it's C over 1 plus 1 equal to C over 2. Okay, if you sketch your F double prime T sign diagram, yeah, this is your ln A over B. So here will be positive and here will be negative. So your part C, when we sketch the graph, okay, So it starts from here, the y-intercept. Then it go up at the inflection point here, ln A over B, and this is halfway, C over 2, vertical asymptote, horizontal asymptote, y equal to C. So it's go in this shape. So if we approach, because we are talking about T, so we stop here. So this is the shape, S shape. Only logistic, only logistic. The upper limit, this is called the upper limit. The inflection point is halfway of the upper limit. Okay, class? Okay, now if I want to plot the f prime x graph. Okay, so we know your f prime x will be always positive. Why? Because there is no stationary point, correct? So your f prime x will go like that. Someplace somewhere here, then it go up. Then after that, it come down, then you go like that. So this is your y equal to f prime x. So there are two inflection points at the f prime x. So your f double prime x, the graph will be positive, pass through this point. Yeah, turn at this point, pass through this point. Okay. So the graph will be positive, from 0. Yeah, I use the black, from approaches 0, it go up. I don't know how it done. Okay, then it come down, then it go up, then it go like that. So you see, the f double prime x is more complicated. So in the exam, we can give you the fx graph and ask you to do the f double prime. So this is logistic function. Are you okay? So you have to remember all this. You can write this down in your notes. This is another important notes that you must write it down. Very important. The differentiation one is not that important, but this one is very important. So your f prime x, your fx sign diagram, and your f double prime x sign diagram all together go like that. Convex, concave. Hello? Are you okay? So go back and study a bit more about this. Hello? Okay, I just want you all to ask you all a question. Have you all tried the curve property question? Okay. I think I better don't ask. Okay, listen here for tomorrow class. Can you please go to Times for tomorrow class? Can you please go to Times and download the question and print out the question on, do you see the kinematic example 1? Kinematic example 2? Please download that, print out the 2 examples. I'm going to teach you kinematic based on that 2 examples. That is under the applications of differentiation. Do you get me, class? Krishanini, you know where to download the question? I don't have physical class. I can't do it for you. Go to Times topic 3. You see another kinematic example 1, kinematic example 2. Both example, please print it out. Please don't look from the screen. Please print it out if possible, so that you can straight away write on it. Are you clear? That is for tomorrow class. Okay, any other question on curve property that you want me to discuss with you? We still have 5 minutes. No? Did you all do your work?